Okay, for today, we're talking about inverse trig. Okay, he calls it inverse functions. And the first thing the kids think of when they think of inverse is like if I said, what's the inverse of sine? They might say cosecant. That's not really an inverse. That's a different thing. So let's talk about inverse versus reciprocal, because if you think those are the same thing, this could be a really confusing unit. So let's make sure you get the difference. For instance, if I take the number 5, what's the inverse of 5? The inverse of 5 is negative 5. It's not the same thing. It's an inverse, okay? But the reciprocal of 5 is something completely different. The reciprocal is 1 over 5. Do you get that inverse and reciprocal are different things? Okay, so then the one where sine goes with cosecant, that is a reciprocal. Okay, so inverse trig, which is what we're doing, is not about this. This is not about that relationship. So when you see this, a lot of times kids go, oh, so you mean cosecant? No. Inverse sine is where you have sine with a little -1 right there. And that brings up what is an inverse function. And you actually learned this before, but I know it's been a long time. Inverses are the things where x and y flipped around. Do you remember that? They're the things where you reflect it over the line y equals x, and then you get the one function would have. Here, let's go back and talk about inverses in other functions. So here's a function, and what's its inverse? Well, let's make this the exponential function. We'll go like this. That's the exponential function. And do you remember that across this line, there was another little function that we called, do you remember what it was called before I say it? Come on, what was that one? I'm seeing evidence of what the calculus teacher said, which is that kids don't remember what their basic graphs are. Okay? Can you label those two? One of them is y equals this, and the other one's y equals that. Do you know the difference? You need to know. We've had a whole unit on these things. No, that's not a square root. Okay. I know we're coming back from break here, and for some of you it's first day back, because yesterday we were just pretty much taking tests and stuff. So that's not x squared. It's kind of like that. It's 2 to the x. Okay, now it doesn't have to necessarily be a 2 base, but it's an exponential. The red one's an exponential. How about the green one? Remember me saying it was kind of like a tree blown over in the wind? What's that guy again? The log graph. Y equals log base 2 of x. Okay, so those two are what's of each other? Reciprocals or inverses? It's a big difference. How many think it's reciprocal? How many think it's inverse? All right, more people at least were on the inverse side. That's good, because they're inverses. All right, so with inverses, there are reflection over that line, y equals x. And that means things like this. Would the point, I put in a 3 here for x, would that equal 8? Does that sound familiar? Okay. Then, if the point 3, 8 is on that graph, then what point would be on the other graph? Say it if you know it. Man, you guys are really slow this morning. Okay, if 3, 8 is on this graph, what would be on that graph? 8, 3. They reverse. Remember the whole x and y get reversed thing? Okay. Okay, so now that's a quick reminder of what inverses are. So now what's inverse trig? Well, what does sine look like? Sine is a wave. Hope you remember what sine looks like. It's been a while though. So here's my sine graph. Could I reflect it across the line y equals x? Yes, but it'll get really weird when you do that. Okay? So the inverse sine is complicated stuff when you dig deep enough. At the surface, inverse trig looks really easy, but inverse trig is actually kind of complex. Because I got to do a reflection of this graph across the line y equals x. Remember how the line y equals x looks like that? Do you get how it's going to be complicated to do a reflection of that? All right. So I've showed you a little bit of what inverse means. Inverse are where x and y get flip-flopped. Okay. And it goes across that line y equals x. Now let's go back to circle trig and make sure you remember how to do simple stuff. Draw me a triangle, even though I know some of you haven't memorized, which is awesome. I told you to memorize it like 100 years ago. Said it would come up a lot. Here it is again, sine of 30. Would you please make me a circle trig picture? That involves a right triangle. That'll give you the answer to sine of 30. I know, maybe you've memorized it, but draw me a picture. Pause for a second. See if we can bring back the easiest of circle trig. Okay, you should have said that's where 30 degrees is. And so then you should have said, oh yeah, I can make this triangle here, and it's got opposite. And 1 goes across from a 30, and this is a 2, and this is a square root of 3. None of them are negative. That's the most common mistake in circle trig. Okay, and then so sine of 30 is opposite as 1/2. All right. I hope that was easy for you. If it wasn't, you need to get this back in your head, because to be able to do inverse trig, we got to do regular trig first. All right, so let's do another one that's similar to that. Would you find me sine of 7 pi over 6? Hopefully you remember where 7 pi over 6 is. Count by 1 pi over 6's. I hope you were down there. And then since these are pi over 6's, they're the same as 30's. Right? Here's where 6 pi over 6 was. We have to go another little bit further. Now we're at 7 pi over 6. Okay. And then this must be 30, and that makes this 1, 2, and root 3. And you knew I was going to throw in one with negatives, right? So this got a negative and a negative, right? No. Can't have a negative on the hypotenuse. But that one's negative. Okay, then, final answer. Sine is opposite of hypotenuse. Negative 1 over 2 is negative 1/2. Okay. Now, what's inverse trig then? That's regular trig. What's inverse trig? Well, let's go back to this first one, the simpler one. Start with that. Say, how would you make this into an inverse trig question? Have you ever seen this button on your calculator? Sine with the little -1? It's a thing. There's a button on your calculator like that. You don't have to go look it up, but it's there. And that button is going to do something. What it is, I like to think of it as just a rearrangement or a rewrite of this original one. You know how the angle is always after the sine? Sine of 30 is 1/2. What if I turned it into Jeopardy and I told you the answer to the question, and I wanted to know what the question was? What do you think the answer to that is? What do you think I should put there on the right? 30. Do you remember how the whole x becomes y and y becomes x things? You remember, you know what I mean? Like the x and the y switch places? It's kind of like that. So here's the angle is at the end. That's an important thing to understand, is that if you're doing an inverse trig question, what this does is figures out an angle. This is saying I've already got the side ratios. Please tell me what the angle is. So when that little thing is up there, I think of it as a little guy screaming, tell me the angle. So if I see this, I think of it as, tell me what the angle is. I know the side ratio is 2 over root 3, but tell me what the angle is. So right away, I take problems like this and I rewrite them as cosine of some mystery angle, I don't know, is equal to 2 over root 3. And then I figure out what angle must it be to make it work out. Now, we usually make these nice ones, like 30s, 60s, 45s, because you'll recognize them. Do you recognize that 2 and root 3 could possibly lead to a right triangle that you know? All right, figure this one out. Hint, it's positive. Just start in the first quadrant. I know some of you are thinking maybe that cosine's also positive down here. Don't do that. I'll use that spot. So step 1, rewrite it to look like this. Step 2, draw the triangle. Remember me saying at the beginning of this semester, you're going to draw so many triangles this semester? Well, I'm still drawing them. Now in the inverse trig chapter, it's kind of like turning inverse trig problems into regular trig questions, except there are restrictions. Like, remember me saying, oh, by the way, just don't use this one down here? I'll explain later why you can't do that in inverse trig. All right, so cosine is adjacent over hypotenuse. The adjacent side is 2. The hypotenuse side is square root of 3. And ooh, that's weird. That's not how it normally is, or you know what I mean? So normally, that's not how it gets set up. So that means I better figure out what this third side is. Okay? And I can figure out what the third side is by doing a squared plus b squared equals c squared, etc. All right? So that squared plus that squared has to equal that squared, right? Okay, so this would have been a lot nicer question if I would have just made it one of the standard right triangles that you already know, but it's not. This side must be the square root of that squared, which would be what? 3, minus that squared, which would be 4. And I have 3 minus 4 would be negative 1. What? But this is adjacent, and this is hypotenuse. All right. So what we just set up is one where you just can't draw the triangle. There's no way to do it. So what do you think the answer is? No solution. Because this can't happen. I can't have a side of a square root of negative 1. We just set up an impossible thing. Remember, it's kind of like if I had asked you a picture. Here's the picture. This is what cosine does. Cosine goes like this. It'd be sort of like asking you, when is cosine negative 5? And you'd say, never. There's no solution for that. It doesn't happen. If I'd have said, when is cosine negative 1/2? Yeah, there's lots of answers for that. But, okay, so I gave you one that didn't work out nice. Maybe a little cruel for your first one. All right, so I'm going to give you one that will work out nice. I bet you'll like this one a lot better. All right, so I hope your first step was to rewrite this as cosine of some angle equals 1/2. You do not have to do that, but that's what I recommend. And then you go over to your picture and you make yourself a picture of where cosine should be, where always use quadrant 1 to start with. Okay. Then cosine of this angle is a half, means I don't know what the angle is, but adjacent over hypotenuse. I do know this triangle. It's the 1, 2, root 3 triangle. And then what angle's across from the root 3 here? That one is the 60-degree angle, so you should have said 60. Also known as pi over 3. 60 degrees, aka pi over 3. Raise your hand if you had that one right. Awesome. Now, if you're good at circle trig, you should have also had this kind of little back in your head going, why aren't we using this spot too? Because there should be 2 answers. All right, let me explain. This is the complicated part of inverse trig. Otherwise, they're really, really easy. You just take this and you rewrite it to look like that, and that's like the circle trig unit we already get tested on? That's all there is to it, except for these restrictions. Okay, these restrictions are that, and I'm going to keep it simple for today because today's a shortened day with math and everything, and I want to get to your homework on time. I'm going to just explain where you can do inverse trig and where you can't. And I'll explain later why it's that way. All right. Inverse cosine can only go from here to here. You can't get an answer for the inverse cosine of 5 pi or 6 pi, no, 7 pi over 6. That would be like right here, you know? You can't do inverse cosine of that. If you tried it on a calculator, it's an error. I'll explain later why. But for right now, you just need to memorize where you're allowed to be and where you're not. Okay, so that one's inverse cosine. They all have their little restrictions that I'm going to mark out for you right now. So inverse cosine is allowed from there to there. What is there to there? That's from 0 to pi. Okay, next, the other 2 are very similar but have a slight important difference. One of them touches, like that one does, and one of them goes right up to but doesn't quite touch. And I got to think through which one it is. Remember how tangent has asymptotes and it can't touch at the asymptotes? Then tangent is the green one. It's so inverse tan goes from there to there. And again, if you know this circle, you know that that's known as pi over what up there? What's that spot? Pi over 2. Okay. And then would you agree that normally it'd be 3 pi over 2 down here? But for just a moment, remember that you could do it with a negative. I don't know if you remember this, but you could also say that that is the spot negative pi over 2, right? Okay, so that's the way we do it in inverse trig. We call that spot negative pi over 2. So that little diagram is half of what you have to do for this next test, is to know where you're allowed to do inverse trig questions. So let's say you were about to answer this question. Inverse sine negative 1/2. And then you go for the rewrite, which is smart. You say sine of some angle gives me negative 1/2. Now let's put up the ASTC thing. Where is sine going to come out negative? Here and here, right? So that leaves me only one choice. You get that in this circle, inverse sine, which is the black one, inverse sine doesn't exist in there. Now you know where you got to draw your triangle. Because of this little chart I just gave you, you can say, well, nothing's allowed here. In fact, we call it the dead zone. You can't use the third quadrant at all for this next test. If you ever find yourself drawing something there, you're doing something wrong. Because none of the inverse trig functions work there. Okay, so now I'm down to, how do I do this? I got to draw myself a triangle in that quadrant, so it's not that hard from there. I draw myself a triangle in that quadrant, and I label it with sides from this angle's perspective that are opposite, and hypotenuse, 1, 2, and this must be square root of 3, and then, oh yeah, that must be a 30. Now, here's the key. Do you remember me saying, also known as pi over 6, do you remember me saying that we were going to use negative pi over 2 here? This answer isn't 30 because it'd have to be up in this quadrant to be 30. But you don't say it's 330. That's what we would have said in the old days, is that answer is 330. Nope, don't do that either. This is the one chapter where your answers to your questions can be negative angles. What do you think the final answer is? Negative 30, also known as negative pi over 6. All right, let's do another one. Inverse cosine of, and I'm going to give you the, not, normally you get the angle, but when you're doing inverse cosine, you give the sides negative half. Wait a minute, did I just do that one? Or did I just do sine? I got to back up a second. I just did sine. Good, yeah, this is different. Don't look at your phone. Put that away now. Okay. Did you start with cosine of some angle equals negative a half? Awesome. Then you start drawing yourself a picture. And this is different than before. You can't just go, oh, there's two places that cosine is negative. The two places are, cosine's positive here and here, so it can't be out. The two places are here and here. You can't just draw two triangles like you would have. Because you remember that chart from a minute ago? You remember how the dead zone was here? You better not use that spot. Cool, that leaves us only one spot, right here. So you draw your triangle right here, and it'll be easy from there. That's all there is to it. Okay. So, how could this get more complicated? Oh, lots of ways. But one of them goes like this. I'm going to finish this problem out. Cosine was adjacent, hypotenuse, and then it must have been a square root of 3 here, right? Okay. Now, what was the angle in question? Well, what angle is across from the root 3? It's normally a 60, but we can't say 60, otherwise we'd be in this quadrant. So it must be, let's use pi over 3's, 2 pi over 3. Raise your hand if you had that one right. Okay, good. Okay, so now here's my question. What if I had actually not wanted the angle, but wanted the tangent of all of that? I know that makes it seems like it's really complicated, but I can tell you the answer already. It's super, super simple. Because the hard part is the inside. And you always start on the inside. Have you noticed that theme throughout this semester? Always on the really difficult problems, you start on the inside of them. Like when we were doing our transformations, we always did the horizontal stuff on the inside first, because starting on the inside is a good thing. When you have nested parentheses, you always start on the inside. So that's a really good theme in math. So if we start on the inside here and we draw all of this out, you do this problem the exact same way. It's just at the end, we wouldn't give the angle. we'd give tangent of that angle. And so really we just have to do tangent now with this triangle. I've already got it drawn, so it's tangent. TOA, opposite, over adjacent. So it'd be root 3 over negative 1. Do you get what just happened there? I just did the inside first, and then I did the tangent of what was left. All right, so let's do something similar to that. Let's do the cosine of the inverse tangent of 1, which, by the way, if they ever just give you a 1, always put it as 1 over 1. Because remember, there's two sides. If it's just a 1, you'll get confused, like, they only gave me one side. They're giving you two sides at once. All right, so how did I say to start? On the inside. So don't even worry about that cosine until later. Right now, just draw me a picture for that spot. Once you've got that triangle drawn in the right place with the sides and the angles all figured out, then just do cosine of it. It'll be easy. All right, so step 1. Take the inside and you rewrite it. Can you do that for me? Tangent of, don't try to guess the angle. Even though you might be right, tangent of the angle is 1. That's how you rewrite. Okay, we're just changing it from an inverse question to a regular question, but we got to remember there's rules about this. So what are those rules again? Where is inverse tangent even allowed? Quadrants what and what? We're only allowed to do inverse tan in 2 of these spots. Can you see them? 1 and what? 4. Those spots are out because inverse tan's only allowed from here to here. Next, I would label them because this used to be pi over 2 and 3 pi over 2, but now it's pi over 2 and negative pi over 2. So now we're in there, but that still would imply 2 answers. Hear me now. There's only one answer to every inverse trig question. So if you get stuck in that whole like, oh, I'm going to find my 2 answers thing, you're back on regular trig. That happens in regular trig, but not on inverse trig. Okay, so which of these spots should I actually do it in? Well, which of these spots does tangent equal positive 1? Quadrant 1 or quadrant 4? Quadrant 1. So this spot's out. Has to be in quadrant 1. Why was that again? Because tangent was positive 1. There's no negative there. And if tangent's going to come out positive, you must be in here. Okay? And then 1 and negative 1. No, 1. Yeah, that's right. No. Ugh, I'm getting confused now. No, that's positive 1. Sorry. 1 and 1. And this must be root 2. And then final answer, well, wait a minute. I'm supposed to normally get an angle, but I don't. I just need the cosine of it. So cosine of this angle, adjacent over hypotenuse. Did you get 1 over root 2? Okay. That's what tonight's homework is like. Find tonight's homework by arrowing down quite a bit. I'll pause until I get there. It's this green page with the branches on it. And I'm going to have you do this first page. It's a little intense to do all of them, but I'm going to have you skip the ones in the middle. And then do all the rest on that page. And on this page, let's skip the middle again. It says watch out for these 2. If you want to see what the problem is, you can go ahead and try them. Arc means to the negative 1. Thanks for bringing that up. The word arc means sine with the negative 1. That means inverse, yes. So arc sine means inverse sine. The only thing I would note on those is if you just always use radians, you're safe. But the ones that say arc, you definitely have to use radians. But just use radians all the time for your answers and you'll be good. I don't mind if you do them. I mean, we all memorized it as 30, 60, 90 triangle. But convert them to radians at the end. We're just going to do those 2 pages. strongly recommend staying caught up on this. The test is going to come up pretty quick. It's going to be early next week. That's all I got for you for today.